Welcome to SaaS Explore. I am Diana Maris, a product manager for SaaS Intelligent Decisioning. Joining me today is Luis Kaufman. Luis, do you want to introduce yourself?
Yes, I'm Luis Kaufman. I work in SaaS as a solution advisor in the fraud and security intelligence solutions, and I work implementing fraud and risk management solutions in SaaS.
Thank you. Today, we'd like to talk to you about SaaS Intelligent Decisioning and how it can be used to ensure fairness in analytically driven decision making. Modern digital transformation is about adaptation to the world we are now living in. It is about reimagining how organizations work to be more nimble, quick, and operate with extreme precision, leveraging both humans and technology. They are looking to obtain the highest value through this. We are seeing the scale, speed, and complexity of decisions accelerating across all organizations. In response, there is a need for a change in the way decisions are being made. Organizations need to work on increasing their capabilities for augmented decision making, where a human takes analytically driven insights and uses them for making a decision, such as the case of a call center, and automated decision making, where a machine is making the decisions, such as credit origination or logistical routing, as well as next best offers. In these cases, there is no human interaction. These are critical capabilities for digital transformation, allowing an organization to provide or to make the best decisions in the moment for every moment. When we are introducing AI-based approaches into decision systems, the impact on people and companies is far-reaching. As such, we have a responsibility to ensure that decisioning systems are adopted without sacrificing security and fairness. Decisions are the result of a larger, well-functioning analytics lifecycle as we navigate from customer questions to data-driven decisions. There are three essential components to intelligent decisioning. Those are data, models, and the derived analytical insights. In the first stage, we look at defining business rules as well as aggregating and processing data in order to introduce it to the analytical process. We make sure that all data preparation steps are governed, meaning the data is available, secure, consistent, and trackable. At the next step, machine learning models can be introduced to automate, predict, optimize, and explain outcomes. As part of the SaaS model ops process, models can be deployed for usage within decisioning systems. Models can be also continuously monitored and retrained in order to ensure the highest performance and value. At the end of the cycle, analytical insights are incorporated into decision flows that can be in turn deployed for usage by a multitude of applications. We manage decisioning with SaaS Intelligent Decisioning. It can be used to satisfy an extensive number of diverse operational decisioning use cases across an organization. Here are some examples that our customers might be coming up with in terms of questions in the realm of fraud, compliance, underwriting, and marketing. If we zoom in on the underwriting side of things, customers could be asking, what are the risk factors or variables that are the most important in predicting the likelihood, frequency, and severity of a loss? With SaaS Intelligent Decisioning, data can be brought into models that can be then incorporated into decision flows within an underwriting process. Business rules as well as streaming real-time data can augment the decision-making process. This will ensure that lenders will be able to meet credit risk and underwriting requirements as well as compliance needs at the same time. which will result in higher return on investment as well as fair outcomes for applicants. You don't need to take our word for granted. Federal regulators in the industry are pressing on the importance of transparency and soundness in the case of using applications for credit decisioning. As recent as May 2022, the Consumer Financial Protection Bureau issued a reminder for creditors of their legal responsibility to provide specific and accurate reasons for adverse actions in the case of using artificial intelligence technologies in credit decisioning. This can only be achieved with a tools that enables users to easily create, manage, and govern robust analytically driven decisioning at scale. SAS Intelligent Decisioning, alongside SAS Model Manager and SAS Visual Analytics, is part of a unified stack of applications on top of our cloud-native SAS Viya platform. They provide the capabilities that we need. One of the big advantages our customers see with using our models is that they are production ready, which means they don't need to be recoded in order to be incorporated in a decision flow. From SAS Intelligent Decisioning, users can also easily switch to an exploration and visualization mode in order to analyze outcomes within a SAS Visual Analytics dashboard. But first, let's take a closer look at what are the core capabilities within SAS Intelligent Decisioning. Decision components such as queries, business rules, and treatments can be easily defined in a low-code, user-friendly decision builder UI. SAS Intelligent Decisioning also provides native advanced analytics integration with SAS's Model Manager interface, as well as the capability of writing custom code in DS2 and Python. Decisions are easily deployed to different destinations such as lightweight container runtime in the cloud called SAS Container Runtime, or SOCR for short, which I'm sure you've heard a lot about in today's presentations. SAS Microanalytics Service for real-time deployment on the Viya platform. SAS in database like Teradata and Hadoop, SAS Cloud Analytics Service for processing in batch or to a Git repository. I will now let Luis show you how these three components, visualization, models, and decisions, can be used in his solution towards mitigating inequitable credit decisions. Luis? So I think that was all of it.
Can I switch the slide? Okay. Okay, I'm ready. Using the SAS Intelligent Decision capabilities, we can implement different use cases. Last year, we worked building a demonstration in how to ensure fairness using SAS Intelligent Decisioning for a loan origination process. We presented this to some customer requirements where they are trying to match any fair lending risk requirement. Also, we present this in Singapore Tech Festival of 2021. Before I start the demo, I want to explain the solution workflow for the demonstration. So basically, we have three personas. The first persona is the risk manager. That is the person responsible to start and review the ADA project. ADA stands for Artificial Intelligence and Data Analytical Technologies. The second persona is the data scientist. That is the persona responsible for building, developing models and decisioning. And this persona will be also testing the impact of these new models and decision. The third persona is the data ethics specialist or the model and decision auditor that is responsible to investigate potential bias and also evaluate the new process from the fairness perspective. During the demo, we'll be covering just the step 2 that we can see in the presentation, where this data scientist will be creating and testing this new decision flow. And the step number 3, where the data ethics specialist will be analyzing the fairness of this new process, calculating fairness metrics, and also investigating potential bias. So let's start the demonstration. I will start this demo by showing something that we call a decision flow. A decision flow is a combination of analytical components such as queries to specifically dataset, internal or external, REST API requests, scoring using machine learning models, business rules such as credit limit definition, if-else rules, specific lookup tables. All the combination of these elements, when we use to solve a specifically decisioning problem, we call a decision flow. For the demo today, I'm going to use a loan origination process for a small medium enterprise portfolio. Let me double click on this decision flow. We have very common elements of any loan origination process in this decision flow. The first one is actually a request to a credit bureau for the credit bureau scorecard. We have a threshold or a limit to approve only low-risk customers given a threshold. We also have the champion challenger process where we assign a random digit variable for every application, and 80% of the applicants will be going to the scorecard where we'll be calculating the credit risk scorecard, and we're going to define a scorecard threshold. The other 20% will be going to the random forest process, where we'll be assigning or calculating a probability of delinquency using this random forest model. And once we use all of these models to reject and approve applicants, we also can define the credit limit that we're going to give to these customers and the minimum interest rate that we'll be using to price this new loan. And for every box or every analytical task here, we can click and understand the input. So for example, in credit limit definition, I'm able to see the input, that is the quarterly sales, and the output, that is the company credit limit. The same for risk premium or the interest rate. I can see the input, that is the probability of delinquency, and the output, that is actually the premium, the risk premium, or the interest rate. Well, when we combine all of these elements, the first question we have to do is, what is the impact of this in production? So how we do this using the capabilities we have in SAS Intelligent Decisioning? Basically, we just need to go to the scoring tab. So we can click in the scoring tab, and here we have a test using a production data set, we have scenario analysis, and we have versioning. So for this example, let's use the new test. Let me show how to create before I show one pre-calculated. So we can click in new test. On the new test, we can select a table. We can define and store the output of this table to analyze in more detail with all the impacts we have, but I already did that, so let me close. And I can go to this test that I did before. How do we do that? I just need to click in the results. In the results, I can see the output table. I can see all the auxiliary variables that we use, for example, to calculate the models. And I can see also the output So for example, the main output variable for this process is the status credit variable. That will be like the target variable of our decision process is if I reject or approve a specific application. I can also do path tracking. That is a visual way to see the flow of the process. So I can click in analysis and plot, and I'm able to see the flow of all the process. Since the beginning, I can see the volume of transactions for any given analytical task. Well, by doing all of this, I'm not able to answer a second question that is becoming more common in this AI machine learning world. How far is this process? Am I have any bias? If I have, how do I mitigate this bias? So we can do this with all the analytical components that are part of this decisioning platform. How we do that? I'm gonna click on the output table, and I'm gonna do an action that open a visualization of this process where we have something that we created that we call fairness dashboard. So let me click. Once I click, I will be open the existing reports associated to the decision flow. In my case is this fairness dashboard. The first tab here, I have a very simple lambda statistics. What is my approval rate? So in this case, the approval rate is 62% if I use this decision flow in production today. Another important thing that is part of all the analytical components of our platform is, okay, combining models, external credit bureau scorecard, external queries, internal queries, business policy. I will lose the track of what are the most important or the most heavy attributes that are make me do a decision to approve or reject a specific application. So we have a capability that we call automated explanation. So we can get from this output data set an automated explanation. So how we do that? I can right click and I can explain the status credit that is the output of our decision process. I already did this, and this is actually this report here. So basically this is an automated explanation, all generated by our algorithms, but the main output here is what is the outputs that are helping me, or they have the biggest weight in my final decision. Because if you see all the decision process is like a decision tree, is a nonlinear process, and basically we can easily lose the track of which one are the most important attributes. But again, here we are not answering the question, this process is fair or not? Am I have any hidden bias? So I can answer this question in the same fairness dashboard. If I click in the second tab, hidden bias, this is a dynamic query. So imagine that you work as a data ethics auditor, model reviewer, decisioning reviewer, and you have access to a protected data set. When I say protected data set, you have a data set with protected attributes that only you know, and you're gonna merge this with the output of the data from the decision process. And we can do this on the fly by clicking data, go into the protected analysis, and click in the data icon. Here we can do a data join, and it's visual. So if I click here, we'll be able to add it visually, this join. So here I have a second table, protected ABT, and the first table, that is the decisioning output. And I'm able to bring protected data such as ethnicity, gender, religion, and region, and many others that this person will have access to. So let me close. by looking only the approval rate for every protected attribute. What is the goal? I want to see if the approval rate is the same for every category of each protected attribute. So the main question that I want to answer is, if I have a straight line in all the categories, at least empirically, I know that there is no difference in terms of the approval rate. But actually we have, and it will always have. So basically I can say at NIST we have a different. So how do we understand where this correlation or this hidden bias is coming from? I can keep using the automated explanation capability. So I can right click. So by right click, I will be able to run the same explanation by ethnicity. And if I click here, I'll be going to the 30 tab of this analysis. So basically in this 30 tab, basically this self-explanation will be actually showing which are the attributes from our decision process that are most correlated with ethnicity for a given ethnicity category. So we can see for white people, we can see for Hispanic, Afro-descendant, and in Asian. That are the categories that we have here. So one of the insights we already have, we have a variable that is the owner income that is part of the models that we use in the decision process, and is bringing this correlation with a protected attribute. Now, what we can see is if I run the bias statistics that are a set that we have out of the box in our procedures, how robust is the correlation of ethnicity and the models or the whole decision? And we can answer this question by clicking this bias statistics. Here in the bias statistics, I have on the left side each protected attribute, but just to illustrate this example here, I can see the common bias statistics that we see in the industry when we talk about fairness. And one of my favorite ones is the demographic parity. So basically comparing white category with Hispanic category. But what I'm doing here, basically, I have a surrogate model that is mimicking the decision with all the attributes we use in the decisioning, using the self-explanation capability. And I'm seeing if the probability of getting approved is the same if you are white or if you are Hispanic. But if the bias statistic value is significant, the answer is no. They are not the same. So basically, one of the conclusions we have here, the probability of getting approved is very different if you are Hispanic and if you are white. Okay. Well, we also have another analysis that we call group statistics. So I observe each of the applications after the approval process. So I observe those who defaulted or become a delinquent loan and those who not. And I was able to use these surrogate models to see how good we are in giving credit for a good customer, depending on the protected attribute. And here I can observe that our model or our decision is not doing a good job for the white category. So this is another insight. How we can use this report to provide a trade-off analysis. So what we can do in order to control this bias. An alternative is trying to propose a competing variable or alternative variable to those who are correlated with the protected attributes. And we do this in this trade-off report. In the trade-off analysis, we have the surrogate model represented by this decision tree. And on the right side, we have all the inputs from the decision process. And here we can see that we have owner income is one of the most important one. And we can bring alternative data by editing the join. So like we did it with protected data set, I can click in data and I can select alternative trade-off. That is the input of this analysis. And I can click in the data icon and edit the join and bring alternative data. I already did this. So if I click here on the right side, I'm able to add this alternative attribute. So I can click in add. And here I can look for alternative data. I'm gonna select number of supplier. So I know the number of suppliers of each company is part of my alternative data set. By doing this, our solution on the fly estimate another surrogate model for our decision, mimicking the status credit. So basically, I can see that I have a potential new segment, number of suppliers, not only increase the ability of the surrogate models to give credit to good customers, customers who won't be delinquent after 1 year. And not only that, I have a good number of applicants that they don't have any observed delinquency, and I can potentially start a new segment. I'm gonna cover this later. Let me show also the additional capabilities we have. One of the other questions we can have is, okay, imagine we don't have any bias or hidden bias, or our process looks fair for all the protected attributes we have. How transparent is the process? So I can answer this question by this tab, SHAP Explainer. So let me click. How this works. Treating the whole decision as a machine learning model, I'm able to change or to recalculate the Shapley values for every applicant. Why? I want to have the transparency of understanding which attributes are weighting in favor as the green bars or are going against the probability of getting approved in my process. So this is also part of the capabilities we have in our decisioning platform. As a final question is, how do we explain the rejected customer? We do this by running something that we call counterfactual analysis. How is this counterfactual analysis works? Basically, we have a customer, 1, 2, 3, and we calculate for every customer 3 closest neighbors, and this 3 number is a parameter. We could calculate 5, 1, the closest approved neighbors, and we compute the difference in terms of the most important variables, such as FICO score, for example, the owner FICO score. And here I can see for the 3 closest approved neighbors of this rejected customer, 2 of them, they have bigger FICO score, one 86 points bigger and another one 66. While we do this, we are able to criticize any threshold we define in our decision process. And the final graphic is how we can see any concentration of a specific attribute related to the probability of default. That is one of the most important inputs to our decision process. And we do this, again, to understand our data and criticize or suggest new thresholds to the whole decision process. Well, what we learn from now, we learn that we have a potential new alternative data to avoid hidden bias. with ethnicity, for example. How we implement this easily in the intelligent decision. Let me show you how. We're gonna come back to the decision flow. And here, we're gonna create a new segment. Maybe we have the opportunity to create a whole new segment for big companies or companies who has bigger than 16 suppliers. How we do that? We right click on the flow. We can add below a new branch. This could be a yes or no, or it could be a range. Let's use a range. Once we do that, on the right side, we are able to bring variables. So let me bring variables. Here, we are able to look for the variables that we learn. They will help us, the number of suppliers. So basically, I'm gonna select number of supplier. With that, I can create the range. I can add a layer here, and I can type the threshold. 16, let's suppose, to 50, for example. And now I have in my decision flow a whole new segment, a whole new path in our process. And for this path, I can easily add a model, for example. Let's suppose for this new path, I want to implement a new model for this specific segment. So I can go to model, look to my model library. I already have a model for this segment. This is low origination risk scorecard, one version only. And I'm gonna bring this model. I'm gonna save my decision. After saving, I can keep redoing the impact analysis, but it's not the objective of the demo today. And basically, I try to show how the connected capabilities with decision flows, origination process, and the fairness analysis. I'm gonna hand over the presentation to Diana, and thank you for your time.
Thank you so much for your attention. If you'd like to learn more about SAS Intelligent Decisioning, head on over to our decisioning homepage. If you'd like to introduce yourself and collaborate with other innovators on communities.sas.com, join the conversation at Decisioning or SAS Hackers Hub. We look forward to hearing from you. Thank you.